Hello everyone, this is Xiaoyu, and this is my part to introduce NAT some basically content. I will introduce the NAT in these three ways. Firstly is introductions of NAT. The next is the advantage of NAT. And the third one is disadvantage of NAT. And finally is some NAT terminology. Firstly is the introduction of NAT. NAT is the abbreviation for Network Address Translation. It is the protocol to translate the IP address with an IP packet handler to another IP address. When an IP packet passes through the security appliances or routers, the appliances or routers will translate the source IP address and the destination IP address in the IP package. In practice, NAT is mostly used to allow the private network to access the public network. NAT provides many benefits, including following. NAT conserves the legally redressing address chain by allowing the privatization of interest. NAT conserves address through application port level multiplexing. With NAT overload, internal hosts can share a single public IPv4 address for all external communications. The next is NAT increases the flexibility of connection to the public network. Multiple pools, backup pools, and load balancing pools can be implemented to ensure reliable public network connections. The next is NAT provides consistencies for internal network addressing schemes. On a network not using private IPv4 address and NAT, changing the public IPv4 address schemes requires the readdressing of all hosts on the existing network. The cost of readdressing hosts can be significant. NAT allows the existing private IPv4 address scheme to remain while allowing for easy change to a new public addressing scheme. This means an organization could change ISPs and not need to change any of its inside clients. And then there are some disadvantages of NAT. NAT does have drawbacks, including the following. The first is one disadvantage of using NAT is reduced user network performance. When hosts inside your network make a request to a remote site, the remote site will see the connection. As it's coming from your NAT router, some hosts implies a level of security regarding how many connections to accept from another host, and they do not respond if they define the number of requests has been reached. This can degrade the performance of your network. Next is hosts inside the NAT network are not reachable by hosts in another network. Because many applications and protocols depend on end-to-end functionality, your network may not be able to use some of them. Hosts inside an NAT network are not reachable by hosts in other networks. Finally is end-to-end IP traceability is also lost. If you need to troubleshoot your network from a remote site, you will find troubleshooting for more difficult and sometimes even impossible. The next is NAT terminology. Cisco has designated some NAT terminology which explicitly refers a set of addresses with absolutely certainty and no ambiguity. That applies to all traffic directions. First is inside local. Inside local means a host that physically exists on the inside network and seen from the perspective of the inside network. Inside global. Inside global means a host that physically exists on the inside network as seen from the perspective of the outside network. Outside local means a host that physically exists on the outside network as seen from the perspective of the inside network. Outside global, a host that physically exists on the outside network as seen from the perspective of the outside network. Thank you for watching.
Hello everyone, I will be talking about translation modes of NAT. So the first one would be dynamic translation, second one would be static translation, third one would be load balancing translation, and fourth one would be network redundancy translation. Dynamic translation. So network address and port translation, an unregistered IP address to a registered IP address. Big amount of internal users shares a single external address in this translation. It prevents external hosts 2 from making connections to internal. Second one is static translation. It allows one-to-one mapping between local and global addresses. It helps to expose a specific service on the internet network to the public network. Next one would be load balancing translation. It maps multiple unregistered IP addresses to single registered IP addresses. It allows you to basically permit thousands of users to connect to the internet using real IP addresses. It works only for stateless protocols. Example would be HTTP. And the last one would be network redundancy translation. Network redundancy translation uses based on bandwidth and availability. It can also be used to provide automatic failover of servers, and the firewall is also connected to multiple ISP.
Hello, my name is Emmanuel, and I am a computer engineer at the University of Cincinnati, and I'll be going over what is the NAT and its main functions. Network Address Translation, NAT, is designed for IP address conversations. Our home devices are connected to a home router, and then the router is given a public IP while our devices are given private ones. And it's all along a linked path. The main functions of the NAT. It enables private IP addresses, networks that use unregistered IP addresses to connect to the internet. NAT allows a single device such as a router to act as an agent between the internet or public network and a local network or private network, which means that only a single unique IP address is required to represent an entire group of computers to anything outside their network.
NAT devices translate internal private IP and MAC addresses so they send from and receive back to a global public address. This is accomplished by editing any datagram sent or received from an external source. If on the same network, hosts will utilize the private network addresses and be able to determine MAC addresses without the need for NAT. However, when sent to an external source from one of these privately addressed hosts, the datagram must be edited by the NAT. When the datagram is originally constructed, it will have the source MAC and private IP address that need to be updated. The NAT removes the private IP and replaces it with the global public IP. often with a port to indicate which host supplied the request. The MAC address will also be changed to reference the NAT device. This datagram can be sent to an external source without revealing internal network addresses. When a reply is received, a reverse of this process occurs, where the NAT determines the source IP and the MAC address based on the incoming datagram. This incoming datagram will have destination addresses that match the NAT device, but with indicators allowing routing to private hosts. This allows for IP and MAC addresses to be obfuscated from public view, but still communicate on a wide network.
My name is Yanling Zhang Graf, and I'm at the NAT group. NAT stands for Network Address Translation, and my topic today is Network Address Translation and Security. By actively dropping unexpected connections, NAT may enhance the security of a network, but it's due to the NAT not knowing how to handle the packets, not to security design. Once a mapping is in the NAT translation table, traffic can reach the internal network. NAT not equal to a firewall. NAT has been developed with a different goal than the firewalls. Basic NAT provides no security. From the security standpoint, stateless NAT is no different from static basic NAT. NAPT does provide some packet filtering functionality. Static NAPT is identical to a simple packet filter. The drawback: NAT routers break the protocol stack layer separation and may break applications. Traceability in case of security incidents is difficult behind the NAT. Reduce port entropy.
This is William Turley with Class 2211, Section 3 of Computer Networking, and we are going to go over the different NAT types. Excuse me, I'm probably going to be looking more at the screen than I am at the camera. But to start off, we're going to go over the quick overview of just what NAT is, just really brief, because I know my previous group partners have already gone to it in length. And then we're going to go step by step over the different types. So, like I said before, we're going to do a quick overview, and then we're going to get into the different types. So, I made the quick illustration to go over it real fast, and just a quick cursory explanation. So we have to talk about NAT. We have to consider how IP version, it's like a band-aid for IP version 4 and its limited number of unique addresses and our slow implementation into IP version 6. What we have is like a type of masking. So as an illustration, I know the drawings are bad, but stick with me real quick. We have a whole bunch of, like, so you have a home, or we're going to compare it to a school real quick, a home with 3 unique private IP addresses, right? So 2 computers and a cell phone, and then we have a router, and that router has a public IP address. So when that server communicates to any of the private IP addresses, it goes to the router and uses the router's public IP address in a forwarding table, right? And each of those has different port numbers that it gets attached to it, which is what we're going to be going into more detail later. And it, when data is being transferred, it takes the table and matches the private with the public, and whichever port number it is. And that's how you can use a whole bunch of unique IP addresses and mask them all under one single public IP address. So it's, if a quick illustration to make that more sense, it's like having a school. You have a school, that school has a set uniform, and all of those unique students wear that one uniform. So that uniform could be considered like a public IP address, and all those unique students fall under that public IP address, and so each individual student could be considered as a private IP address. So if I want to give information to a student in a school, in order to consolidate things, I just say that, oh, this uniform is associated with this school, so therefore that private IP address is underneath that public IP address. So that's just a quick overview, and now we're going to get into the types. And I'm going to try and cut down on time because I know I don't want to cut into my group members' time. Okay, so first off we have Pat, and Pat is very similar to what we discussed in the overview. We're using basically translation of the private IP addresses with the attachment of the port numbers into the public IP address, and that's used with forwarding tables and communicating and how they match together. So real simply, I know it said we're going to do more detail, but because we spent so much time in the overview, when they're so similar, that this is going to be really quick. So simply, you have multiple unique private IP addresses, like we explained earlier, and those can have a port number attached to it or overloaded onto it, and to what becomes the public IP address, which encompasses all those private IP addresses, and that's what's used with communicating with outside servers. And that translation and matching is done through forwarding tables, and that translation becomes more important when we start getting into dynamic. But for now, that's it for Pat, which is the most common and what we see in pretty much a lot of private homes and stuff. Okay, so next up is static, and static is very similar conceptually to Pat with what we did earlier, but the main difference is that it's a one-to-one situation. So you have, let's say, people visit the public IP address, and that one public IP address gets translated to a single private IP address. So if you have somebody doing a call with a request for information or something to pull from a server, and that they type in this public IP address, and it goes to the router and only goes to one other private IP address. It's just that server. So very similar to Pat, but we're just doing it on a localized one-to-one scale. Not localized, but you know what I mean, just a one-to-one. So finally is dynamic, and very quickly, dynamic is different in that it uses what's called a NAT pool, which is a list of a bunch of public IP addresses. And so what you have is a private IP address when it goes to the router, and when in the process of its translation gets changed to one of the first available public IP addresses pulled from the list, or the pool, the NAT pool, and that public IP address replaces the one that's the private IP address before it gets sent out. And the difference is that, at least compared to static, like what we talked about before, is that the dynamic NAT deals a lot more with outbound traffic than incoming traffic. And that should cover all the